Hello, welcome everybody. My name is Julia Egerer from EASA. I'm the section manager of the Aerodrome section, and I'm very happy and grateful to welcome you to this webinar, to our second webinar on the GRF, the Global Reporting Format. We're very glad that so many of you have taken time off today to explore with us how we in Europe have implemented the global reporting format that assesses and reports runway surface conditions almost 2 years after the regulation applies. You know that the regulation applies since 21st of August 2021. We have experienced 2 winters now with the global reporting format. And while it's a very sunny day today here in Cologne, and I hope you also enjoy some sun today, we will talk about weather, we will talk about snow, and we really look forward to this exchange with you. Before we start the sessions, I would like to remind us about some house rules on how we have planned to organize this webinar. And I would like you to ask, please switch to the next slide, please. Thank you very much. We are planning to use Slido. You have 2 options to use Slido to interact with us during this webinar. You will find on the bottom right-hand side of your WebEx that you have just joined, you will find an icon called App or Apps. If you click on that, the Slido app will open, and you can basically use it directly from the WebEx to answer you put your questions in there. And also, what's the most important thing, if you don't have a good question, you can also vote for a question that you like. And we will primarily answer, of course, those questions that have received the most likes. The other option, if you don't want to clutter your screen with too many things, you can also now take a screenshot with your phone of the QR code that you see on the slide. And then you will also enter into Slido, and you just have to put the passcode in your phone, SNSARX, which allows you then to have the Slido app on a separate device rather than your computer. You have those 2 options. Please note that we will only answer questions that come from Slido. There is another function there that's called chat. Please only use that if you have logistical problems, if you cannot hear anything, or if there's a problem, then we will monitor this chat for some logistical questions, but we cannot monitor the chat for questions that have to do with the content of this webinar on the global reporting format. So for that, we will use the Slido app. Now, the next slide, please. I would like to introduce you a little bit to the topic of today. Why do we have a webinar now after almost 2 years of using the global reporting format? As you know, as I already said, this new methodology applies in Europe since August 2021. We particularly opted in Europe to apply this regulation already in the summertime, so that those of you who are living and working in the Northern Hemisphere can have sufficient time to adapt to this new way of reporting the runway surface conditions, and that when the first winter starts in 2021, you're already fully prepared and know what you have to do. So that's what Europe decided, a little bit different from ICAO, but we wanted to give you enough time to implement this change. We know now that after almost 2 years, and especially after 2 winter seasons of working with the global reporting format, of course, we have gained a lot of experience. And that's one of our top objectives of this webinar, that we allow this forum to share experience and to have a common understanding of what is working well, and of course also to enable us to get your ideas and your suggestions on how we can improve the implementation of the global reporting format. Because any regulation is not set in stone. surely after almost 2 winters or 2 years of working with the global reporting format, and there will be things that we will realize now that we might not have thought about when we first developed this regulation. Our third objective is that we want to promote good practices. While we are in Europe and we all work in our different parts of the world, different parts of the aerodrome environment, in different parts of Europe, sometimes it's difficult for us to look outside and see how our colleagues implementing the regulation in other parts of Europe. And that's why, and even in other parts of the world. And that's why we also organize this webinar. So we give you a forum to see how the member states, the authorities, but also the industry, the aerodromes have implemented the regulations. So that brings me to the agenda of today. You will find the agenda with all the names of the speakers and the exact timing of this webinar on the EASA website event. So you should have that in front of you so you can better follow the timing, but I will take you through the webinar today and make sure that we take the breaks that we promised we will take and that we stay on time. You will hear today, first of all, from some key stakeholders on how they implemented the global reporting format. You will hear from authorities, you will hear from airlines, and you will hear from airports.
Just a second, I got some messages that there is no sound.
Okay.
But
please, if there is difficulties with the sound for many of you,
here's
put that.
Here.
Okay.
For me. Seems to work.
So there are people saying that sound is okay. Thank you very much for letting us know that this might have been a problem or of somebody's computer. Of course, this can also happen and we cannot control that. So it's good to know that most of you can hear me. So going back to the agenda of today, we will hear from the main stakeholders, authorities, airlines, and airports. We will also get some feedback from our colleagues here in EASA, mainly in the domains of ATM/ANS, aerodromes, and air operations. And then we will also have enough time, hopefully, at the end of the webinar. We will start this at 12:15 to have an open forum where we will take your questions. We will mainly take the questions that you have liked the most. That's why Slido is such a good tool, we believe, so that we can have a live session with you to answer your questions. Now, for answering your questions, please keep in mind that the question must be short because there's a limitation for Slido, and that you already use that while you listen to the presentations, that you already use that time to put in your questions, because that will make it easier for us to screen the questions that we're getting in or the comments, and to then assign it to the different panelists. So before we now start the webinar, I would like to remind especially the speakers that will now speak to please stick to the allocated time slots. We cannot afford more than 15 minutes per speaker. Otherwise, it will be difficult to have sufficient time for the questions. And on Slido, it's very important for us that we also try to interact with you as much as is possible in this virtual environment. So please try to stick within the 50 minutes. If you're going over the allocated 50 minutes, I will give you a short warning while you are presenting, just to make sure that we can stick to our time schedule. Now, what we have really tried to do in this webinar, we have tried to make a very good geographical balance of the presenters that you will hear in this first part of the webinar. So you will hear from stakeholders coming from the north of Europe, from the south of Europe, and from the center of Europe, because we know, of course, that weather conditions differ quite a lot in different parts of Europe. And that's why it will be most helpful for all of us who come from different parts of Europe and have to deal with different weather conditions, that we make sure that we have a good geographical balance. So you hear and you can learn, and we have the possibility to share experiences from aerodromes and authorities and stakeholders that come from different parts of Europe and that have to deal with different types of climates. I would now like to hand to Alexander Gundal from the CAA Norway as the first speaker, who will talk to us about specially prepared winter runways. Difficult to imagine on a day like this. We have really beautiful sunshine here in Cologne, but this is one of the specialities of the European regulation, of course, that we have a special rule on specially prepared winter runways. And we are quite proud of that we have achieved to make sure that you can also operate in these very harsh winter conditions, and you can operate safely in those harsh winter conditions. Alexander Gundal is a CAA Norway inspector and aerodromes inspector. And without further ado, I would like to hand over to him so that he can start his presentation. Alexander, the floor is yours.
You hear me now?
Yes, we can hear you now very well, Alexander. So the audience should be able to hear you because we can also hear you here in Cologne. The floor is yours. Your presentation is still in, yeah, now it is in presentation mode. Very well. Thank you so much.
Yes, hello everyone. My name is Alexander Gundal, and I'm an aerodrome inspector for the CAA Norway. And I'm going to talk about how we implemented the specially prepared winter runways in Norway. The regulatory challenges, the ADR OPS B036 of the EU 139/2014 introduces the use of specially prepared winter runways.
Alexander, just I need to interrupt you because we realize now that on the screen we are seeing what's called in PowerPoint the presentation mode.
Okay.
So we are seeing the screen with your annotated notes.
Now?
Maybe now, yes, now it's very well, and we can actually read what is on the screen, because before it was just difficult to read what was on the screen. So
yeah.
Now great, and I hope that you can now continue with your presentation. Thank you very much.
Yeah. As I said, the regulatory challenges was in the ARD OPS B036 of the EU 139/2014 introduces the use of specially prepared winter runways that under certain conditions permits the reporting of runway condition code 4 when our runway surface contaminated by compacted snow or ice is treated in certain procedures and certain procedures are applied. The aerodrome operator needs an approval from the CAA in order to use SPVR, but the aerodrome needs an approval, so gathering data seemed to be impossible in this. So in order to give us SPVR approval, the CAA Norway had to grant an exemption from certain requirements in the regulation 139/2014. The basic regulation contains flexibility provisions in Article 14.4 in the event of unforeseen circumstances or operational needs of limited duration, provided that the level of safety is not adversely affected. This relates to regulation of 139/2014, in particular points the OPS B036, B2, and B3. One fundamental requirement relating to use of SPVR is that the aerodrome operator must obtain aircraft data that relates to stopping performance on the runway with a special treatment from at least one air operator. According to AMC1 in the OPS B036, B3 and its guidance, the data must be collected from minimum 30 landings, and the statistical level of confidence shall be 95%. The aerodrome operators documented in their application that operational procedures and staff training are in accordance with the new requirements. They were in place. Agreements with air operators to submit aircraft data were in place, and how they made data processing. They have long experience with winter operations, and the equipment were in place, and the risk analysis were in place, etc. CAA Norway then issued a prior approval to use SPVR for data collection purposes. The approval was granted for 1 winter season, or until they had collected data from 30 landings with a statistical level of confidence of 95%. The prior approval had a set of terms. the aerodrome operator had to follow, for example, if more than 2 out of 30 consecutive landings, the experienced braking action is below the reported braking action, the use of SPR4 shall be terminated until the local safety action group has assessed the situation and taken action action to correct the process, including the use of materials to improve the runway surface conditions. CAA Norway shall be notified if this happens. And there was more. During the data collection period, a NOTAM must be issued. This gives the operators the possibility to add an extra margin, for instance, by including a runway shortening as applicable. And then you have the final approval. After the data collection period, the aerodrome operator applies for a final approval to use the SPR. CAA Norway then issues a final decision and includes SPR in the terms of the aerodrome certificate. And the status by February 2023 is that we have 19 applications for SPR. 2 are finally issued. Received a very limited number of notifications of mismatch between the aircraft data and the reported runway condition code. And the indications is that both the Airbus 320 and the Dash 8 are reporting the same braking data values. And as in Norway, we have a high focus on the winter operations among the aerodrome personnel. The one minor issue we have discovered is that ATIS message can be very long, and we have to look into that. And that was a short version of how we implemented the SPR in Norway. So that's my presentation.
Thank you very much, Alexander, for your presentation on how you have implemented the specially prepared winter runways. I already see that we are receiving questions in Slido, so that's very good. Please continue, dear audience, to use the Slido to upvote questions that you find specifically interesting, or if there's something that you didn't quite understand in this presentation from Alexander from CAA Norway, you can also use Slido, of course, to clarify your understanding. But now I would like to move to the next presenter, and that's Katrin Stoibli from FOCA. Katrin Stoibli is also an aerodromes inspector from the FOCA, that's the Swiss competent authority. And she is the project manager for the implementation of the global reporting format in Switzerland. So without further ado, Katrin, I'd like to hand you the floor and also remind you of the 15 minutes maximum speaking time. Thank you very much.
Thank you very much, Julia. Can you hear me?
Yes, we can.
Okay, perfect. And do you see my presentation?
Yes.
Very good. Okay, thanks a lot. Thank you to EASA and especially also to Basileos for giving me the opportunity to present the implementation in Switzerland. So that's how the winter looks in Switzerland nowadays. You see there's not much snow, but we still go skiing. Snow is rare nowadays, but it doesn't mean that the GRF would be useless, as we still have some snow days and now and then also some rain periods. So I would like to give you a short overview about how we implemented the GRF in Switzerland from a CAA perspective. And I would also talk about the challenges we are still facing nowadays. So before I start my presentation, I would like to present myself very quickly. So my name is Katrin Stoibli. I'm working for the FOCA for more than 4 years now as a project manager aerodromes and also an aerodrome safety inspector. So let's start with the topic. Here you see an overview of Switzerland, like a small map, and you see all the aerodromes with a small point, and those with the flash you see where the GRF concept is implemented. So we have about 83 civil aerodromes in Switzerland, including also the heliports, the airfields, and the bigger aerodromes like Zurich or Geneva. And 19 of those aerodromes, they are affected by the GRF. So the scope for the affected GRF aerodromes, here you see the criteria. The first criteria was that all the certified aerodromes certified according EASA or ICAO, which means there are 13 certified aerodromes. They're all in the scope of the GRF. And the second criteria was that aerodromes on which aircraft take off and land with a maximum takeoff mass of more than 5,700 kilograms are also included in the scope. We decided for this criteria because we talked to several experts and we come to the solution that these 5,700 kilograms is about the mass of the also small business jets, and they use the GRF information, so we included also those aerodromes. For the smaller airfields, we didn't implement the concept, but they still publish the runway surface condition, but on other channels like per telephone or on the internet on their website, and not according exactly to the GRF concept, as they don't produce a runway condition report, for example, and no snow time. So our concept during the implementation was to inform the stakeholders as soon as we had also familiarized with the new system. And then we developed the concept for the implementation in Switzerland. We did several workshops with all the stakeholders, especially with the aerodromes, but also with the ANSPs and the aircraft operators as well. And during this time, there were also some detailed questions still open. For example, how to deal with the discrepancies between the EASA and the ICAO requirements. But then finally, we decided to go for the EASA requirements for the whole country, just to make sure that we have a nationwide concept for each aerodrome the same. And during this time, we were also very thankful we could contact the experts from EASA and also from the Friction Task Force to clarify specific questions. We also received now and then from the aerodromes, and this was a good support we could get there. As I said, the workshops were very interesting as several stakeholders like aerodrome ANSPs and also pilots were participating. Among the workshops, we also developed a guideline to make it easier for the aerodromes to implement the new GRF. We tried to break down the whole system on some papers to inform them how to implement, just as a guideline for them. And in collaboration with our ANSP Sky Guide, we also developed the runway condition report specification Switzerland, which was also a document prepared for the aerodromes to make it easier to inform them how to prepare and to publish the runway condition report. So then in the next phase, when the implementation in August 2021 was over, we started with our oversight activities the next winter. Here you can see some pictures from the oversight activities. We went to the aerodromes to verify if the new requirements were being met at the aerodromes. And we observed that the aerodromes have implemented the system. Even there were also some difficulties depending on the local conditions of the airports. But this could have been solved in the meantime. So we can say that the system is implemented over the whole country. So now I would still talk about some challenges of the GRF implementation that we are still facing nowadays. One of them is the publication channels of the GRF. So for the bigger aerodromes, we don't have really an issue on this topic because they have SNOWTIME publication, they have a ATC, and they also have a ATIS where they can publish this information. But we have some troubles with the smaller aerodromes that may only have the possibility to publish a SNOWTIME, but they have no ANSP on place, they have no ATC and no ATIS. So it makes it challenging, especially for to obtain updated information concerning the runway condition for pilots approaching the airport or airfield, and they might don't have a system in the cockpit to reach the information published on the SNOWTIME. So this is just an overview what I said before. It works well on the bigger aerodromes, but we still have some challenges on the smaller airfields, especially if the condition changed to really inform the pilots or the operator about the new condition. Then the next challenge we are still facing nowadays is the ATIS, and there especially the ATIS length and also the ATIS publication period. For us, the challenge is that we publish the ATIS. We publish on the ATIS the same information that is on the runway condition report. So it means the same information pilots get on the SNOWTIME, they also get on the ATIS, which means we also include the situational awareness section on the ATIS, as we believe that it can be interesting or information that pilots need can also be in the situational awareness section, which makes the ATIS quite long. And especially for aerodromes with 3 runways, as example Zurich, we only have one with 3 runways, so it is Zurich. The ATIS is quite long for these situations. And the second challenge on the ATIS is the publication period, which means that we also publish the ATIS, or the aerodromes publish the ATIS during the whole publication period of the runway condition report, which means that on the last phase they publish 8 hours a runway condition report for a dry runway, and they also publish a ATIS for 8 hours with dry runways. And this also leads to information that pilots might don't need anymore to be informed about the dry runway during 8 hours on the ATIS. So this is a bit our challenge concerning the ATIS, especially as I said before, for big aerodromes with several runways. So this is already everything I wanted to talk about, and we think that the GRF brought a safety benefit in the whole system, and it is implemented worldwide, we can say. So we think there is a big safety benefit, even if there are still some topics we are still challenging with. And we would also like to thank EASA for their support, and we appreciate they supported us during the implementation phase and also nowadays to make it even better, the system. Thanks a lot.
Thank you very much, Katrin, for this interesting insight into the Switzerland and how you have been managing that. So we can now see your screen, which is your outlook, so you can stop sharing.
Okay. This looks better already, but I will.
This is much better. I like this picture a lot. That's beautiful. Yeah, so thank you very much. We've now heard from two competent authority experts, aerodrome inspectors, who have really supported their industry to implement the global reporting format. And I think we also have to say how well this is working across Europe, that the authorities are taking a very important role in supporting the industry to implement the changes and to work with them, and also to provide feedback on us, like you have done, Katrin, also on what is working not so well and where you see some difficulties. This is very much appreciated. I have received some questions in the chat that you cannot access the Slido. So actually, just before we move to the next speaker, I would like to remind everybody, you can go to the bottom of this WebEx and there is an icon with three little squares. And if you click on that, it's called apps. You can open the Slido and it opens inside your WebEx. You also have the option, and I put this in the chat, to access Slido via the normal website with your telephone, your mobile phone, and then you type in a certain code, GRF 2023, and the passcode SNSARX. So that's the other option that you have. And then you can also make sure that you have access to Slido. So I hope now with this clarification, you can all access Slido. We are already receiving questions and we are answering them. We try to answer some of them as they come in as well. So I would now like to present the next speaker, Mr. Heinz Konrad from Lufthansa Group, who will now give us the point of view from an airline, an air operator, on how they have been implementing the regulations. So thank you very much, Heinz. I hope you can unmute yourself and share your screen.
I should be unmuted and I should have shared the screen. Do you see it?
Yes, we can see your screen and we can hear you also very well. So
Perfect.
the floor is yours for the next 50 minutes. Thank you very much.
Yeah. Thank you. Yeah, I have some more slides. I need to hurry up, I'm afraid. Thanks, Giovanni, for inviting me on this webinar to share an airline group's view on this. Airlines have to convert whatever is reported together with the runway data and the surroundings like obstacle information into something that is useful for takeoff and landing performance calculations that the pilots are required to do before takeoff and landing. And as an airline, we had to go through various documents, and most prominent is the EASA air operations, of course, but we also had some aspects with the certification, with how it is reported and what do aerodromes do. From the national regulatories, we have some guidelines on how they will report. I presented here the Canadian, the Austrian, and the German. I didn't find the Swiss document, the AD note that Catherine was referring to. Sorry for that, but we looked at all of this. There have been some very good ICAO documents. The airplane performance manual was very good. And then there was the circular 355 about the assessment reporting of runway service conditions. And of course, last but not least, we had the manufacturer data. First of all, the flight crew operation manuals that we received with aircraft, flight crew training manuals, and the performance data itself.
Sorry, Heinz, for interrupting you. It's not something that I like to do, but I wanted to make sure that you are aware that you have enough time. Actually, we have moved on quite quickly with the other presentations, so you don't have to feel stressed at all. You have enough time. We have now still a full hour actually planned for your presentation and then for the presentations from Victor, from Jens, and from Ronnie. So it should definitely work out.
Okay.
I don't know now from the top of my head how many slides you have, but I think it should be okay. So you don't have to hurry up that much.
Okay.
People who said that the audio was not so good, but for us here in Cologne, it was excellent, the audio. So I don't know why they had problems with the audio. For us, it was good.
Maybe suggest people use a Chrome browser.
Okay. My colleague here in Cologne is just telling me if you have problems with the audio, which happens sometimes apparently on WebEx, you should try to switch to the Chrome browser from a certain company starting with G. So hopefully this is going to solve your problems. If you use the Chrome browser from Google, sometimes it works better and you have better audios. Yeah, so the problem seems to be then on your end, because here in Cologne we have very good audio. So Heinz, sorry for interrupting you on this, but I realized that I might have stressed you a little bit by telling you that very little time left. You should have enough time. We still have an hour left, okay?
Okay. I talk a bit slower then, and this will help for those that have audio difficulties. At the same time, we started a major harmonization task within, firstly, Austrian, Swiss Air, and Lufthansa. And so this was our first combined effort, our major project in harmonizing the flight ops between those three airlines. Later on, Eurowings also joined the group. And what we did is, first of all, we drafted what we call the GRF Compendium. It was a comprehensive document aimed at all the departments that are affected within the airline, showing what's going on, what are the changes, how are things done, what are the things you should take special care for. We drafted this and sent it out to all the other departments. We remained available as a focal for the implementation, and also for the departments that do the training documentation. And yeah, the documents that are affected within an airline is typically the operations manual part A, providing the definitions, policies, general limitations. We have the operation manual part B, those is aircraft specific data and aircraft specific limitations. And the operations manual part C, which holds the country specific information. We refer to it as the route manual. This was relatively easy because the countries all provided some documents, as we've seen on the previous slide, about how they will implement GRF, what special things they have in reporting conditions and so on. Furthermore, this information went into the training documents that we had for the different departments, like there was in GRF web-based training, an in-flight landing distance web-based training specifically for those aircraft that where the ILD was a new concept, and of course, last but not least, for some airlines use homemade or in-house made performance applications for takeoff and landing, and those have to be updated as well, so they could reflect the new performance data that come with the TALPA recommendations. I split it now up between landing and takeoff and start with landing. For landing, the implementation was really smooth. This is maybe not a big surprise since the whole TALPA effort focused mainly on landing. So we expected that that would come out of it made sense. What helped, of course, was the delay. We would not have been really ready by November 2020. So Corona, that was one of the maybe the only positive thing of the COVID disease, that we have moved it to August. And also starting it in summer was, in my opinion, a good idea looking back. Since then, that was the slides that Catherine showed. The winters have not really been hard. Winters have been mild, and that maybe also helped. And what helped for those that operate Airbus aircraft, Airbus already introduced those new landing distance data about 10 years, more than 10 years ago. By the time GRF was implemented, I think it was 10 years. So a majority of our pilots already used and understood the concept of those in-flight landing distance data. We have a reporting system, a flight report system, where crews can give their opinion on things, or if they have reports, can report that back to the back office. And from what I looked there seemed to be no great problems and pain points from the pilot's point of view. They understood that how to deal with different runway third reportings, like using the lowest runway condition code, checking whether the whole runway was needed for landing, and maybe omitting runway third that has a poor code. or shorten the runway in some cases. So they managed to work around the global reporting format. There we didn't. I'm not aware of bigger problems. In our performance application, landing performance application, we installed the matrix so the crew can get in there and see the data, so they don't have to look up in the operations manual. They can just select from this matrix the landing condition, and maybe they have to do it 3 times, or if they use the lowest, they can have to do some more work. But basically, it turned out to work fine. The discussions we had when implementing landing was, some of the discussion points was, what about a cross-check between the Talpa landing data and dispatch landing data? We found that it shouldn't be generally mandated. It might not make sense if you have a 12-hour flight in front of you. It doesn't make sense to use to make a cross-check. So if you have a short flight, however, and at your destination the same snow temp is still valid as when you left or planned the flight, then you should maybe look into a cross-check, because for contaminated runways, the new distance data might be longer, and consequently the landing weight might be less. One part that we didn't think about at all unless we started was the naming of the baby. I mean, EASA used the term LDTA and suggested that it's unfactored. Airbus used for quite some years the ILD, the in-flight landing distance, for unfactored, and the FLD for the factored. Boeing used OLD for the operational landing distance. You also find operational LD, OPLD. And then there is talking about TALPA, of time of arrival, of en route, or in-flight landing distance. Since this is valid for Operation Manual Part A, which is unrelated to a specific aircraft type, we had to decide, and we found that ILD, FLD, and in-flight landing distance is the term we go with. And then during the rulemaking, prior to implementation, there was a discussion whether crews will be able to receive runway condition reports in a timely manner. I don't know how that turned out. There have been concerns that maybe if you approach Munich airport and you have to do the analysis at top of descent, you might be in a foreign airspace, basically. And would they have the means to give you the runway condition report already? When do you receive the data and so on? I have not heard about problems with that. So I'm not sure whether this turned out to be an issue or not. It was a concern, but I didn't hear from it anymore. Maybe people in the know from the air traffic controllers might answer that. Some minor topics we found was the use of not reported in the GRFs. The first example is from the same airport within 2 hours. Once they reported the dry snow with not reported, once with 1 millimeter and one with 3 millimeters. Both is runway condition code 5, meaning probably it was less than 3, meaning a wet runway. But here crews are concerned if there are different, if there is room for interpretation, that's not very good. And the feedback was make it the same everywhere. Maybe use 3 if it's 3 or less. Likewise, with the coverage reporting, sometimes there's the rule saying less than 10 is not reporting, or dry is not reported. Not reported is always ambiguous. The feedback was here, if it's less than 10, write 10. And if it's dry, only write not reported, because that's obvious. The specially prepared winter runway was another topic where we had some confusion because of the colloquial use of the word prepared or specially prepared. So there was the understanding that a sanded or chemically treated runway was already specially prepared, which of course is different, because the specially prepared winter runway is a term in its own right, and it's a reporting condition. And we had to put some emphasis in the trainings material on that this is really not an illegal upgrade to a runway condition code of 4, but that is really a runway reportable condition in its own right. And last but not least, that was a joke we were frequently making. What does a G in GRF stand for? Because it can't be global. Each country, or at least the major regulating bodies, all had their own interpretation of the format, like the AMSCR in Canada, the FICAN in the US, and the SNOWTEM in Europe. All are a little bit different, all try to do the same, but it's far from global. There are some regulatory things we found during the implementation. I've already relayed them to Giovanni Cima, and I won't read this. This is things that we believe should be amended in the regulation or should be looked at least. The second one is already fixed, by the way. That was in 1st of February this year. It was fixed, so the first and the third are still something regulatory could go in. Last but not least, we have to rely on data that the manufacturers give to us. The TALPA landing distance data from Airbus were presented more than 10 years ago. It's what we call SCAP data. It's a standardized computerized airplane performance. It's the way databases and software that the manufacturers provide us with performance data. Airbus also took some effort in providing the dispatch landing data for those conditions that might be reported in the GRF. The number of reportable conditions was amended due to GRF, so we need some data for this as well. And they provided comprehensive recommendations in the FCOM and FCDM, and in fact, they did a really good job on that. So for a lot of other manufacturers where we are lacking this information, we refer to the Airbus FCOM recommendations and flight crew training manual recommendations. Yeah, that makes sense because it's the same physics. Embraer was compared to the first deadline a bit late in providing the data. That was December 2020, and for non-normal landing conditions like flaps up landing, engine out landing, and so on, the data was not published until November last year, really. For Boeing, things look a bit different. You have to request the data to be included in your flight crew operations manual. In SCAP, you only get the data for 747-8 and 787, meaning the newer aircraft, also the MAX, I believe. And there's a statement that they won't provision any data in the SCAP modules for older aircraft. And what they say is, in the absence of a regulatory requirement, our impression was that entities led by the FAA don't honor the fact that EASA already did rulemaking, and unlike the FAA, didn't just rule by advisory circulars. There is a document how you can convert the data into TALPA data, the data that you have, but those are not really comprehensive because they are missing some problems. For example, I can calculate for an older aircraft a wet runway, but that wouldn't allow me to include reverse thrust credit because wet runway is 15% increase of dry runway landing distance, and there's no reverser credit. But if I go to the good runway condition, I'm at a constant mu value and not any longer by a speed dependent mu. So this is not nice. We managed to find some solution in each case, but yeah, it's not. We would like really to get the manufacturers all on board on the GRF and provide the data necessary. We didn't receive recommendations in FCOM or FCTM. However, we received TALPA data in SCAP for all the non-normal conditions for the older aircraft. That was very good. Dispatch landing data have not been amended to reflect all reportable conditions, but the newer aircraft have dispatch and TALPA data on the same producing the same landing distances. And this is something we like actually, and we would like to in the future have only one set of landing distance at all. I know that the flight test harmonization working group is addressing this. They harmonize wet runway and maybe someday also dry runway data so that we are back to one set of landing data. Now the real challenge comes when we start for takeoff. And here the first one is we account for different runway thirds. Finding a conservative approach. I have provided here a little chart. It's the same runway and it's 3 different winds. And the standing water from 3 millimeter to 12 millimeter. And as you see, depending on the wind in this case, either the high depth will give you the best result or the least conservative result, or the low depths can give you the least or most conservative result, or something in between can also give you. So what we told our, when you have discrete contamination depths like some aircrafts have, it's easy, you do all the discrete steps and take the conservative. But then we have aircraft that publish their data as a function of depth. You can enter really any value. And here we told the pilots, stick to what is reported because it might not be conservative to calculate with a higher depth. Now with Runway Thirds, you have to do at least those 3 calculations to find out that the depth is conservative. Reporting in Runway Thirds is, however, no new concept. NOTAMs already had it, but our pilots' feedback was that they actually never saw a SNOTAM. If you flew to Scandinavia, you were likely to see one, but the rest hardly ever reported in Runway Thirds. So actually, dealing with the Runway Third was a new concept to our crews. Also, SNOTAM was an EASA thing, and it existed before, but the pilots had it in their performance training at school, and then thereafter, most likely, they never saw it again. Then there was the saying that GRF is actually the eyes of the pilot on the ground. This is okay, but we expect our pilots to have the takeoff performance calculation done before pushback. Assessing the runway condition and doing the takeoff preparation when you are at the runway already is too late. So this doesn't help much that pilots can look out and estimate the conditions.
Sorry to interrupt you. It's Julia here from EASA, the moderator. I need to make sure, nevertheless, that people actually have enough time for the next presentation. And I realize now that you still have some 3 slides to go, right? Now, please, could you try to finish at around 11 o'clock in 4 or 5 minutes? Because
we'll do.
Have time for the following 3 speakers, and we would like to finish this first panel at 11:30. So thank you very much for your cooperation.
Okay. So then there's upgrade, downgrade. Brings you immediately outside the performance model that is certified in the flight manual, and then you have to do fleet-wide decisions, what to do about it. In fact, you have to abuse your data from the flight manual to match the conditions that are reported. For example, you don't have the compacted snow data typically for the warm temperatures. You can decide as an airline to disregard the temperature spread, but always use compacted snow data. You can decide for not taking credit of an upgrade, but then if you are on an icy runway, which has been upgraded to slippery wet to a 3, what do you do then? You have to decide whether you tell your crews, in that case, use slippery wet, or tell it, no, it's still ice, don't take off. That's decisions you have to do. And then what is about 2 millimeter dry snow reportings? If you have AFM data for 2 millimeter dry snow, should you use them or should you still consider it as wet? What we did is we built a takeoff RCAM, same as the regular RCAM, where we tell crews for each individual aircraft types what we expect them to do. If they find certain conditions, what should they use for calculation of takeoff data? And we also stress that if the format, the runway condition report is really odd, maybe it's okay to delay the takeoff and wait until some cleaning or mending of the runway is done. Then I come again to the data provision. Airbus has the AMC 25-1591, the old version for all their fly-by-wire Airbus, and that's those that we operate. Slippery wet has been added, and they now can calculate a runway condition code that is different from the contaminant that is reported. So for downgrading only. Embraer has this data, and that's about it. You have to mimic whatever is on the runway. And Boeing, I made this table here for different certification status because it's really different here. And you have to use this data. You have to understand what is in the data to be able to use the best possible match for what is reported. So for takeoff, we see at the moment still a great discrepancy between your AFM data provision and what is reported. And that's, yeah, with that, you will get the presentation. I don't need to read over the data. That's about it from my side. Sorry for holding you up.
Thank you very much, Heinz. It's important that we also hear from an air operator's perspective how you have implemented GRF and what have been the challenges, and especially dealing with the manufacturers of the aircraft themselves. So that was an interesting insight from an air operator. So thank you very much for this. I would now like to hand over to Victor Manuel Samoso Pascual from AENA. AENA is the Spanish aerodrome operator, and Victor is head of safety and certification division at AENA. And he's going to tell us how they implemented the global reporting format GRF in Spain at the Spanish airports that are under the leadership of AENA. So Victor, I would like to give you the floor and make sure that you have audio and that you are able to share your screen. Please try to stick to around 10 minutes because we would like to finish this session now at 11:30. For all of you participating in the webinar, we will upload all the presentations on the EASA website together with answers to all the questions. So of course, we will not be able to answer all the questions today, but we will take time to answer all the questions, and then we will upload those answers to the questions together with the presentations on the EASA website. So now I would like to hand the floor to Victor. Thank you very much.
Victor, that last view that you had was great in terms of the screen where you were sharing the presentation. Now we're in preview mode, but you look like you're still muted at the moment.
Let's see. Victor, can you hear us? You can also type in the chat if you have some difficulties. Then we can move to the next speaker and we just...
Yes, I can hear you now. Sorry.
You can hear us. Okay, very good.
Okay.
Was it possible for you to share your screen?
Yeah, yes. Can you see my screen?
Yes, very good. Yes.
Okay.
And now
okay.
you in presenter in the right mode, so that's really great. So we can see the screen very well. We can see you. We can hear you very well. And so thank you for taking the time, and the floor is yours.
Okay. First of all, thank you, Julia, Vasilios, and EASA in general to give us the opportunity to share our experience in the implementation of GRF procedures in Spain. I am trying to talk with you about these topics. First of all, what is the characteristics of AENA airport network from a climatological point of view? What challenges we are facing regarding GRF, and which type of technology we are analyzing and assessing to improve the procedures. First of all, we say that AENA operates 46 airports and 12 airports in Spain. As you can see here in the map, we have airports in around all Spain, but the main airports are in the coast, no? In the Mediterranean coast mainly, and the island. Which type of meteorological characteristic we have? We have soft winters. Soft winters compared with Central and European or North European standards, and hot summer. We have a more serious winter here in the North Plateau, and it's quite soft in the coast mainly. So we have a snow plan for not all airports, only for 20 airports who are affected by snow and ice condition. But really, we have there are no problem that we face yearly. We have it's quite irregular in some airports to have snow conditions. So rain is the most common meteorological condition at airports here, especially in the Cantabrian and Atlantic coast in the northwest of Spain, and in the Mediterranean coast in the east. We have in autumn cold fronts with heavy rains commonly. So, as I say, rain is the most common meteorological condition that we report with GRF, and the consequences of rain, which imply wet or standing water contamination on runway, is quite difficult to determine in some occasions, because the difference of just 1 millimeter depth of water can change the runway condition code, the runway CC, from 5 to 2. That is who has a very much critical impact on the performance of the aircraft. So, in these circumstances, what challenge regarding GRF we face in the day-by-day activities? First of all, we must say that runway assessment, of course, are necessary to report the runway condition, but also the presence of a runway inspector in the runway affect the runway capacity, of course. This is also aggravated by the fact that the runway assessment needs to take account plenty of information. Also, it's quite difficult to detect significant changes in the runway. This is not an easy thing to do with having permanent equipment on the runway, assessing the depth of contaminants, the depth and coverage. Also, we must take into account that runway inspection under adverse weather conditions are not easy for the staff in terms of risk, visibility, workloads, etc. As I say, precision of 1 millimeter of water of snow film depth affects in a very critical way to the runway CC, and to assess this to get this precision with visual and manual assessment is quite difficult. No? So we need special equipment to make that decision correctly. Some adverse weather situation can change very quickly, even in a matter of minutes, and then that can cause issues with real-time reports. In our experience, for a regular rain case, runway assessment takes too long, even if you are publishing the most simple message. If we are talking about usual condition of rain and runways that comply with the regulation in terms of drainage and maintenance, to have the possibility of notifying the information without entering in the runway would be improvement in the procedure quite significantly. And finally, it's also important to take account that none of the equipment that is currently developed by the industry can help us with all these issues, and none is certified by the authority. When talking about a snout or contamination, the different solutions that industry has developed are not precise in the detection of the different contaminant we need to differentiate. And also there are normally not equipment specifically designed for the airports. So what type of technology we are testing now? First of all, I will talk about mobile sensors that measure the depth of contaminants. These are placed in the back of the runway inspector vehicle and measure usually depth of water, ice or snow, coverage of contaminant, temperature, humidity, friction, and so on. It has advantage and disadvantage, like all things in life. No? Advantage, easy to install and to use. Of course, its assessment are quite quicker than manual or visual inspection and much more precise in certain parameters. And of course, they provide plenty of information of the runway because they take a high number of measures. Disadvantage, that the sensor has to be plugged inside the car for power supplying, so a window must be partially open. That is disgusting for the staff, or of course you can modify the vehicle. The sensor do not distinguish all type of contaminants. The capacity of runway are affected. In case of snow, you need to manually assess other RCR parameters, especially what type of snow you have. And of course, every time you remove it and put it on the vehicle, it has to be calibrated. Other equipment that we are use is the permanent sensor embedded in the pavement of the runway. Its characteristics are similar to the previous one, but and measure more or less the same parameters, but with sometimes of particularities. Advantage, are easy to use, and you can monitor certain parameters in real time without entering the runway. Disadvantage, the installation is more difficult. Do not distinguish all type of contaminants. The measures are limited to the location of the runway, and of course you need to complement the assessment of the runway with other type of equipment. And finally, we are trying to assess a different type of technology. We have defined it as a RCR tool that involves rain gauge and software to assess the runway. This is a solution oriented specifically to rainfall condition. Well, it is consists on the installation of 3 rain gauge along the runway outside the runway strip. These gauge collect rainfall data and a software that takes into account these measurements and the characteristics of the runway, produce the message. It allows the production of real-time reports, but as I say, only under rainfall condition. It's very used to use. It produces real-time reports, and no visual inspection of the runway are needed during rainfall. But a disadvantage is limited to rainfall condition, as I've said, as is of course is the most expensive solution. Bien, good. Our conclusion about this item is that there is no technology that can provide a complete GRF assessment. Also, none of them are certified by the authority, and it could be the very high interest that this equipment guarantee that they are complying with aerodrome regulation. By now, depending on the traffic characteristics of the airport, what we are considering is that there are 2 types of solution. First of all, for airports where occasional interruption of the operation are not a big issue, may opt for mobile sensor and combine with some embedded one. But big airports where runway capacity is a big issue may opt for the RCR tool and some kind of a mobile sensor for winter conditions. And well, that's all I want to say to you. Thank you very much for your attention.
Thank you very much, Victor. That was a very good example of letting us know that you still say that there is no ideal technology available on the market right now to support the global reporting format and the runway surface condition assessment. So I think that was a very good pros and cons of different technologies that you have experienced now in using. Just for the audience here, EASA is now working on a research study on runway friction measurement, where we also look into new technologies like laser technology. So we know that there is a need to look into technologies, and we are also, I mean, not we as EASA, but the European Union is investing money into research to make sure that we can really be at the forefront of modern technological solutions that enable us to have good analysis and good data that really is needed to make sure that we can use these new technologies. So thank you very much for this. I would now like to hand over to Jens Essers, who is speaking to us very close to Cologne, just on the north of the river, where here he comes from Düsseldorf, and working at Düsseldorf Airport and is responsible for duty traffic management. So I would like to hand the floor to you, Jens.
Okay.
And,
yes.
I'd like to remind you, if it's possible, to stick to 10 minutes, please.
Okay.
Let's see if this is going to work in the spirit of good Cologne and Düsseldorf cooperation. Yes, it seems to work well. Great.
Can you see my presentation?
Yes, yes, we can. Thank you.
Okay. Hello, everyone. First of all, I want to thank EASA for the invitation to present our implementation of GRF at Düsseldorf Airport. Before we start the presentation, I would like to introduce myself and my colleague beside me. My name is Jens Essers, and I'm a duty traffic manager at Airport Düsseldorf. And since the year 2016, I've been working more intensively on the topic of GRF. Next to me is my colleague Volker Castellan, also duty traffic manager, who has been working more intensively on this topic for 3 years. In our presentation, we will focus on the following issues. First, we want to give some general information about the DUS airport, our responsibilities in winter operations, and the most common weather conditions in our area. Then we will focus on our preparations for GRF and the subsequent trainings, go on further into the implementation process, and conclude with a few comments on challenges and benefits. So we start now with some general information about our airport. We operate with 2 runways. Both are of concrete and are partially grooved and grinded. The runway lengths are 3,000 meters and 2,700 meters. Both runways have a width of 45 meters, and both runways have displaced thresholds. In the year 2019, our best year in history, we had 225,000 flight movements, and we had 25 million passengers. We come now to the next point, our responsibilities in winter operations. At the Düsseldorf Airport, the duty traffic management is responsible for the winter operation plan. That means the creation and the yearly update. We also plan, process, and monitor the winter operation. We do the runway condition assessment and the reporting. And we are documenting shift reports, snow temps, and runway condition reports. The last issue of our general information are the most common weather conditions in our area. Our main wind direction is southwest, so our main landing direction is 2-3. The temperatures in winter are often around the freezing point, and we have frequent changing conditions. We have less to do with loose contaminants. If it occurs, it is wet snow or even slush. More we have to deal with frost, precipitation on a frozen surface, freezing rain, or freezing fog. So our winter operation mainly consists of the use of runway de-icing fluid and less of snow removal. In recent years, we have had fewer and fewer real winter days in our area. This fact is also important for our next issue, the preparation and training of GRF. In our department, we are organized in such a way that the various topics of aviation are distributed among different people. So two duty traffic managers have always taken care of the topic of friction for years. This included regular participation in events and meetings according to friction measurements and GRF. For example, the DGAC Symposium 2016, meetings of the German ADV Task Force Runway Friction, or the ICAO GRF workshops in 2019. Thus, we are always in exchange of ideas with other airports. According to the GRF implementation, two duty traffic managers were assigned by the accountable manager to train the other team members of the department. In coordination with the safety management and the EASA compliance management, we created the training process. The training documents based on the ACI ICAO GRF training course tuned to those circumstances. The basic training starts in autumn 2019 and were completed in December 2019. We decided to train in small training units, that means groups of 2 or 3 people. Our consideration was that all team members had a theoretical background before the winter season 2019, so that we could work simultaneously with the GRF in our winter operations. Unfortunately, we had no real winter conditions in 2019, so this plan didn't really work. We had no chance to collect any experience values. Due to the postponing of GRF to the year 2021, we saw the need to perform a recurrent training course in autumn 2020 with the same considerations we had the seasons before. In winter season, we had nearly the same weather situation as 1 year before, so we had only 3 days of real winter operation. Even this year, it wasn't possible to get practical GRF experience for all of the team members. Before I will come to the implementation process, I have some notes, the documents and the training process itself. We think that the ICAO ACI worksheet was well intended and a nice theoretical construct, but for us, it wasn't really useful in practice. One could say sometimes it was rather confusing. During the training, we recognized no real resistance towards the new format. The GRF was seen rather as evolution, not as revolution. The only uncertainty we sometimes mentioned was the fact about dealing with or without the friction tester in future. So we now focus on the implementation process. With air traffic control DUS, we had an arrangement to perform a 4-week trial period before the official start of GRF in August 2021. This time the plan works and all participants were practically introduced in process and communication. So we had a nearly fluent transition from test trial to official GRF start. During the initial situation, sometimes small uncertainties occurred according to the reporting direction of the runway code. We sometimes heard from ATC the inquiry if it is reported in landing direction or from the lower runway designator. And sometimes we had some ambiguities about the information which is given on the ARTIS. For example, when we report wet runway with the runway condition code 5 in every third and the condition wet, the only information on the ARTIS sometimes was only the runway condition code 5 without naming the contamination wet. Finally, we think that starting GRF in August instead of November was a reasonable measure. And let me now come to our last point, the challenges and the benefits. The challenges in DUS remain the common winter conditions in the last years and probably in the future, which affect training and education. Above all, training and education of new team members. Often training is only theoretical, so we see the need for yearly recurrent training, not only for the GRF, but also in winter operations. Another big challenge, but I think not only in DUS, is the loss of winter ops experience due to the retirement of older team members. In the last year, for example, in DUS, we lost round about 100 years of duty traffic management experience due to the retirement of 4 colleagues. What we noticed since the introduction of GRF is the increasing number of snow temps associated with the chemical treatment on the runway and also associated with aircraft de-icing fluid on the runway. And another thing in a few situations was that runway condition code 5 in combination with a wet runway and in combination with strong wind, more than 30 knots, leads sometimes to limitations in departure and arrivals. Finally, I will come to the benefits of GRF. First, we think GRF increases safety. Before GRF, runway condition assessment in our department was limited to the winter season or in case of exceptional circumstances. Now runway assessment is our daily business. In this context, we also recognized an improvement of collaboration and communication with air traffic control in DUS since the implementation of the GRF. We also think GRF enables a bit more flexibility, for example, the assessment in high traffic. In total, we regard the implementation of GRF as a success. That's from my side. Thank you very much for your attention.
Thank you very much. This was a very interesting presentation as well, giving again a different perspective from a different aerodrome operator here in Düsseldorf, focusing on training and also focusing, of course, on this big topic that we have with shortages of staff. And it was interesting for me to see that your overall assessment is positive and that it has also led to some benefits with regards to cooperation with the ATC.
Yes, of course.
Yeah, thank you very much, Jens. I already see that there were some questions in the chat, in the Slido. And now I would like to move to the last presentation before we go for a break. And that presentation comes from Ronny Andersen from Avinor. Avinor, of course, is the Norwegian aerodrome operator, also like AENA, responsible for operation of several aerodromes in Norway. Ronny is the airport manager at Honjasvak Airport. I'm not sure if I pronounced the airport. I'd like to give you the floor, Ronny, to see how you see it. We started with your colleague from the CAA Norway this morning, and now we finished with you from the airport in Norway. I think it is a nice bracket. So I give you the floor and would kindly request that you stick to 10 minutes, and then we can make sure that we can still have a little break before we jump into the next panel.
Thank you very much. Can you see my presentation?
Yes, and I remember that picture was quite breathtaking when I first saw it in preparation for this webinar. Yes, I can definitely see it.
Okay, first of all, I will thank you for the invite to share some experience from Avinor's implementing on the GRF. And like you said, I'm the airport manager at a small airport, northern part of Norway, and also the project manager for implementing GRF in Avinor. As you can see here, we're quite a long way from where you are today. And the airport is the closest airport to the North Cape. North Cape is a landmark travelers for hundreds of years. And it's one of the 18 or 19 airports in Norway that use the specially prepared winter runway. In Honningsvåg, half of the landings in the winter season are on contaminant runways. And half of these, again, are on specially prepared winter runway. 23 of Avinor's airports are north of the Arctic circles. Many of these airports are the small airports, using only the Widerøe as the small airliner. But we also have some bit larger one who uses Airbus and SAS and some other companies. Winter operations. Avinor got the first signs or signals on this in 2015, state letter in 2016. And we start to have meetings to meet the GRF recommendation. In the rulemaking task, Norway got 4 out of 10 participants, and that was quite important to us due to the specially prepared winter runway. In 2017, the CAA set up a task force to meet the regulation from the EASA. For us, GRF starts like 12th of August, of course. All system up and running. Training the plow crews almost completed. We start to report on wet conditions. We had an agreement with Navlu and Widerøe to receive flight data to qualify for specially prepared winter runways. And we also had this specialty program for airports qualifying for the specially prepared winter runway. Only 2 airports matched the approval for specially prepared this first winter season due to lack of flight data. This winter season, we still struggle to get enough flight data to qualify the remaining 16 airports. This is just an overview of the Navlu solutions. This is from Gardermoen. But we use that data into this, where every one of the airports can see. We matched the runway condition report with the flight data, so everyone can see how they did on the last landing. This is from Alta, Tromsø, Gardermoen. We can see that our reports from reporting the runway condition report 5 and the flight data matched that. And this is from mostly the SAS airliners, but also some Widerøe and some other airlines that we can get Navlu data from. Winter maintenance and track reporting, especially prepared winter runway. Like I said, there's 19 airports trying to qualify. It's kind of important to us. It's a runway with a dry frozen surface of compacted snow or ice or both, which has been treated with sand or grit, or has been mechanically treated to improve runway friction. We applied for a prior approval from the CAA. We have airplane data related to the stopping performance, and statistical level of confidence for the number of landings where the reported runway condition code was deemed the same as or better in the experienced runway condition, and level of confidence at least 95%, like the CAA told us a bit earlier today. Most parts of Norway, winter is business as usual. Some airports have winter operation 5 to 7 months. This winter has been, these numbers are from last Thursday, 139,151 landings, and 26,000 of these are on contaminant runways. So 19% of all landings in Norway are contaminant. 2,600 and more landings are on specially prepared winter runway. And like I said, we receive flight data from Navlu, or the Airbus 320 Neo especially, and Widerøe. This is some data just for some airports, like Gardermoen has 19% of every landings, Tromsø has 44%, Alta 59%, Kirkenes, who is the airport nearest the Russian border in the east of Norway, is 60%, and SB is Svalbard, who has 57% of all landings on runway condition code 1 to 4. So the winter operations, airport operations are carried out when it's necessary, at least 2 times a day. We have lots of extra inspections. The triggers are air traffic, changes in air temperature, dew point, surface temperatures, wind speed or directions, rain, snow, frost, drifting snow, preparations on runway, sunrise or sunset, or airplane data, and of course pilots' reports if we receive some of those. Winter operations, developing contaminant and runway conditions, downgrade or upgrade criteria of use is precipitations, air temperature, dew point, surface temperatures, wind speed or directions, local knowledge on weather. IRIS is a Avinor system for predictions of runway condition. Measuring of contaminant depth, vehicle behavior, shoe scraping, sand or chemicals, airplane reports, pilots reports, or friction measurements device. This is the dashboard or the where we send the runway condition report from the vehicle. The inspectors use this, and we have a fully automated chain going to the Eurocontrol EAD, like this shows. This is a total overview winter season so far. Like I said, we have 139,000 landings. We can see that there's 2,600 on the specially prepared winter runway. We had 578 where we have received flight data, and we have a 92% match so far. What we have learned, upside. GRF was a new way of thinking for supervisors. Matching runway condition report versus flight data gives us valuable information. ARCAM is more accurate for Norwegian winter conditions, and we have the fully automated reporting chain. And of course, we experienced some downside as well. Forgetting old format has taken some time for some of our supervisors. Getting the conclusion when we match the flight data versus the runway condition report is challenging for supervisors. And like most of you experience, winter changes, more temperatures around 0 degrees, even in the northern part of Norway. So all in all, if you fail to implement the specially prepared winter runway, all that's left is memories of air traffic. So thank you. That's all from Avinor.
Thank you very much for this interesting experience from all the way on the very northern hemisphere of the globe. Thank you very much, Ronnie. That was really an interesting presentation, and I actually wasn't aware that your airport is so far north. So thank you also for letting us know where you are located right now. We would now take a break. It is 11:36. And we will take a break for 10 minutes. So I would suggest that we return at 11:45. That's not really 10 minutes, that's 9 minutes, but 11:45, let's come back, okay? Thank you very much. We will be back here at 11:45 for the regulatory experience. Bye.